Okay. All right, so we are starting on, I'm not seeing any notes, so I guess we're ready to start. So 5.4 today, so it should look like this. So this is 5.4. Hopefully you're seeing my screen. If you're not seeing the screen, someone please let me know because I should have shared it. 5.4, our objective today is basically we want to kind of get a preliminary understanding. So understanding and graphing logarithms. So understanding and graphing logarithms is our goal for today. So we've kind of already talked about exponentials. I'll be going over and doing some review information about exponentials for those who just joined the class. But today is the goal of basically understanding what a logarithm is. So I think it's a little easier to understand the graph if you understand what they are first. So I am going to basically be skipping down to page 3. As a reminder, if you need for me to pause or you need further information, you can just send me a quick chat or unmute your mic and just tell me what you need to understand. Okay, so we're on this page. So where we are is part D. That should be basically page 3 in the notes. All right, and we're talking about what a logarithm actually means. Okay, so when we talk about, for example, if I do 2 to the power of 3 equals 2 times 2 times 2, that is 8. So what I have is that this is the exponent, and this is the answer. Okay? When I change it to a logarithm statement, so basically you're switching out your input and your output. All right? I can say right here, 3 is essentially the input. So your input is your exponent, and then your output is your answer. And when we do inverses, we basically switch the input and the output. So a logarithm, the base is your operator. So basically I'm doing a logarithm. It's log base 2. So note that the base is still the same. So here's base 2, here's base 2, okay? What am I changing? Essentially is what is my input and what is my output. So now my input is 8 and my output is 3. So when you do logarithms, one of the things that can be really helpful is essentially, I always think about them as a reverse set. So that is my answer. And this here is my exponent. So this is my exponent that gets me the answer that I want. So this star thing is really important. What are logarithms? They are essentially the exponent value, okay? Also a reminder, when it says log, that is an operation. It is telling you to do something, okay? It looks kind of funky, but essentially it's a math statement, okay? So let's start with this, that essentially a logarithm is an exponent, and a logarithm is the inverse of an exponent set. So any exponent set, I can switch it out and change it to a log set in exactly the same way that I can switch a squared set, so x squared equals 4 or x squared equals 10 is exactly the same thing as saying the x equals the square root of 10. So they mean the same thing. It's just how are you stating the problem set, okay? So if we're looking at this practice here, all right, so if we're looking at it, what we want to do is say, okay, if we're just trying to switch it, first of all, identify your base. So if I look at A, the base is 5. So if I switch to logarithm, the base is still 5. Base is always the base, okay? Then here is my answer. So that's what changes for my input. So log base 5 of 625, because essentially I could put parentheses on there. Log base 5 is the math operation that I'm doing. It's like saying I'm taking the 5th power, only I'm taking the 5th log, okay? So log base 5 is my math operation. 625 is what I'm operating on. And then my answer is X, okay? So if I look at B, log is my operator. Okay, base is the base. So base is X, base is still X. Exponential base X, logarithmic base X. Log base X of what? Well, of 64. And what does that equal? That equals my exponent. Okay. So this is just practicing switching from one type to another type. All right. We could also kind of, as a standard set, I'm not going to do C.
So I have a question.
Yeah.
So the exponent would be 3, right? So it'd be that same exponent?
Yeah, except I wrote exponent because I was thinking about something else. Let me fix it. It is 3.
Okay, awesome. I just want to make sure it's the same exponent.
Yes, I just didn't write it right because I was thinking, okay, let's define this. So log base, okay, answer equals your exponent. That's kind of how they switch, okay? So base is base, but logarithms give you the exponent value as the answer, okay? So that's changing from exponent to logarithm form. If you change it back, of course, we can change it back. It's the same idea. So you identify the base. Here's my base. My base is 3. So that means that's still my base. 3 raised now to an exponent. Well, here's what I had on the outside. So basically, that's my exponent. And what was I doing it on? X. So there's my answer. Okay. So basically, since they're inverses, the notation is funky. Okay. Because it's a logarithm. So the notation is a little weird. But essentially, and it looks weird because essentially now we're getting to kind of, you know, we don't have regular notation anymore. So someone made this up at some point when they were going along and we need to do this. And so now, since we had exponents as little numbers, now we're still using a little number, right? But basically, notice exponent as a little number is up high, all right? And a logarithm as a little number is down low, okay? So that's partially kind of how you can tell it's an inverse is basically, and what am I inversing? Because it's different than taking like a square root, okay? All right. All right. Okay, so Base is high, base is low. So that's one of the things I look at. Okay, so there's a base. The base is the same because that's telling you what you're doing. I'm using the number 3. And it's basically where your variable is on an exponential. On an exponential, when we're really looking at them, the variable is in the exponent. So on logarithm, okay, the variable is the operator. So 3 is basically your base for both of them, okay? So if I'm doing the other one, base is e, so e. My exponent is the x. My answer is the 5. So e to some power is equal to 5. Log base e of 5 is the exponent I was looking for, okay? M is my base. N is my exponent. Two is my operator, okay? So if you'll notice, essentially, they kind of switch places. So basically, x goes from outside all by itself into the equation. 5 goes from inside the equation to outside as the answer, all right? So that's kind of how you kind of think about them. I actually do have to think about them as the exponent set. I cannot actually do logarithms without thinking about them as exponents. So obviously, if you have a calculator, your calculator can help you out. That's pretty straightforward. But if you don't have a calculator, I always actually have to kind of convert them into a format, all right? So if we're looking at finding our values, all right? So let's do a couple of these. If I look at my values, log base, I'm looking at B here. So log base 2 of 32 is x. So what am I looking for? 2 to the power of x is 32. Whether I write that down or not, that's how I personally think about it. I switch it back to exponential form because it's a lot easier for me to think about it as 2 times 2 times 2, whatever, is 32. And I can see that 2 times 2 is 4, times 2 is 8. Essentially, x is going to be 5. All right, so x is the exponent I'm looking for, so x is 5 here. All right, if I'm doing a little more funky one, then I have to kind of be thinking about what that is. All right, so let's look at E. E is a little weird. Okay, 7 log base 7. So 7 is my base, 7 is my base. Okay. Equals square root of 7 on the outside. Equals square root of 7 on the outside. Okay. And then to the x. Well, I can see, to me that makes more sense. All right, but I can see I have 7 to some power equals square root of 7. So I'm going to use the idea. So this one I'm going to switch the format. 7 to the x, and I'm going to change this 7 because I know a square root I can write as a 1/2. And then essentially, since 7 is the base here, and that's exactly the same base as here, that means if 7 is the base and 7 is the base, that means my two exponents, the x as an exponent and the 1/2 as an exponent, have to be the same value. So this one happens to be x is 1/2. Okay, so right now we have A, we have C, we have D. I want you to pick 2 of those and tell me the answers in private chat. Okay? So I want you to chat me privately and tell me the 2 answers that you found for 2 of those. You don't have to do all 3, but you have to do at least 2. Okay, so I'm getting some answers. Getting mostly correct answers and a couple of errors. So the errors are interesting because that's where we can learn things. So if you guys got it right, that's great though, because you got it. We understand it. That's awesome. Okay, I am giving points for this. So if you don't put it on, if you don't give me an answer, that means you're getting 0 for your work for today. Okay, because you guys should be online and you should be answering unless. Okay, if you can't print the page because there's something wrong, maybe you can do it on separate paper or, yeah, that's fine. Okay. If you're having problems, I can understand that because I know it's a little bit challenging. Okay, the rest of you, I'm waiting for some kind of answer. Some of you are a little confused. That's fine. If you haven't quite got the answer, just send me a text and say, you know, I'm still a little bit confused, and I want you to talk about it again. But if you try it on your own, you'll actually know where you're confused. Honestly, if all you're doing is watching me do it, then you're going to be great. I'd honestly much rather get you with a wrong answer than no answer. At least you have a wrong answer. We have somewhere we can figure it out what's going on. You have no answer, then I don't know what's going on, neither do you. Okay. Okay, so I'm seeing, let's look at these answers. All right, so first of all, let's change them back or change them from log form to exponent form. So first of all, identify your base. There's my base. My base is 3. Base remains the base, okay? Then what happens is you got to switch out your input versus your output, okay? So right here, 9 is my input, X is my output. Let's do that. That is input. That is output, okay? So now X becomes the input and 9 becomes the output, okay? I had 2 main answers coming through for this one. I had people tell me X was 2 and people tell me X is 3. If you did X is 3, please note that the answer is 2 because this is not a multiplication problem, it's an exponent problem. So 3 to the 2 is 3 times 3, because your only actual number in that problem is actually 3. So if you chose 3, then what you did is you said, okay, I know 9 is 3 times 3, and you're very close, but the thing you're looking for is how many times do I repeat, okay? So I'm looking for the exponent to make that true. So it is not 3, but if you got 3, you did understand it was a multiplication issue, okay? So next problem. Base is 6. Exponent is x. Okay, by the way, you do not have to do this. It's just that I personally cannot do this unless I switch it back. Okay, unless I'm looking at it in exponent form, I do not know. So what I'm looking for is 6 to some power. 6 to some power is equal to 1. Okay. So 6 to some power is equal to 1. And the only power that returns a value of 1 is actually 0. So that is actually a defined number. So hopefully I did get a couple different answers on this too, but x has to be 0. Okay. Let's just look at it. You don't have to write this down, but 6 to the 1 is 6. 6 to the negative 1 is 1/6. 6 to the 0 is 1. So anytime we get an answer of 1, then my exponent has to be 0 to make that happen, okay? Because any other value is going to be some power of the base. So 6, 36, and so on. I don't know, it's 6 times 6 times 6, whatever. 1/6, 1/36, and so on, okay? So either very large numbers or very small fractions, and then 0, 1 is kind of your, I don't know, default set, okay? So base on this one is 5. Exponent again is x. Trying to figure out the exponent, it would give me an answer of 1/125. Most of you did get that this had to be negative, but I got a couple of different negative answers. So I did see x equals -2, x equals -3, and x equals -5. Those are the 3 different answers that I actually saw. Most people were correct. The answer actually is this one. For me, negative exponents, think about what it was before without being negative. So what I think about when I'm doing these, okay? So my thinking, we're going to write it down here, is if I do 5 squared, I get 25, 5 times 5. 5 cubed is 125. 5 to the 5th, I don't actually know that. That's a pretty big number. I don't have, let me see. Let me think of that. 5 caret 5, what is that? Oh, that is a big number. So I just did that on my calculator because there is no way I can multiply that out in my head. 30,125. Okay. If I make them negative, yes, this is why we're reviewing this. I just had someone tell me that, yeah, I wasn't thinking exponents, I was thinking negatives. So that's why we're reviewing this, so we remember it's exponents, because it's very easy to make that mistake. That, oh, that's a negative number, a negative exponent, and then you're saying 5 because 5 times 5, 5 times 5 times whatever. Anyway, so if I do 5 to the -2, then my basic rule is, okay, that's 1/25. So the way I do is I do this one first. What is it? If it's just squared it, and then, hey, it's negative, so turn it over, right? So 5 squared is 25, so 5 to the -2 is 1/25. 5 cubed is 125, so if I put it negative, then it's 1/125. So essentially, I think about them as positives because that's easier for me to think about. And then the negative, like this one, it flipped over, so it's got to be -3. That's essentially my mental thought processes on these kind of problems, okay? That was not actually notes unless you want to add something, but it's not this one and it's not this one. So those were good guesses though. I prefer a guess versus no guess. All right, so that defines kind of what a logarithm is. And now we're going to go back up to page 1. Maybe it's, yeah, page 1, all the way up to page 1. Go. Okay, so our goal then, all right, so now we understand what a logarithm is. It's the inverse of an exponential. What we want to be able to do is graph this set, okay? The logarithmic function is the inverse of your exponential function y equals a to the x, okay? So if we're talking about a to the x, okay, domain and range for a to the x, wait, my color coding is backwards. Hang on, we need to start over. A to the x is red. Okay, y equals a to the x. So my domain that one blue. Okay, domain and range, okay, on the red function, a to the x. Domain is negative infinity to infinity. Range is 0 to infinity. Exponential functions have a key point at 0, 1. They go up very fast on one side and pretty much flat on the other side. So one side is flat and the other side is very tall, okay? So if I think about my basic set of numbers, and also this is where my a value is bigger than 1. So basically the basic set, okay, x, a to the x. If I put it in -1, I get 1 over a. If I put in 0, I get 1. That's essentially the key point. All right. If I put in 1, I get a to the first. If I put in 2, I get a squared. All right. So on one side, it goes very large because I'm first squared, cubed to the 4th power to the 5th power, etc. On the other side, very small fractions, 1 over a squared, and so on. Okay. So this is the graph we talked about last week. All right. Since it's an inverse, so these, essentially a logarithm, essentially the definition of a logarithm is the inverse. That is what it is. That is what it is, okay? And that's why it came about, because we wanted to be able to inverse an exponential set. So inverse, okay, and that means I'm going to switch my x and y values, okay? So domain and range. So what I'm thinking about is, what I want to do is think about switch. So domain for the logarithm, and that's the blue graph, domain for the logarithm is 0 to infinity. And range for the logarithm is -infinity to infinity. So that's your default, okay? Domain is restricted and range is not, okay? So domain of my logarithm is the range of my exponent. And the range of my logarithm is the domain of my exponent, okay? So y inverse, switch. So I switch the x and the y, and I also switch the domain and range because that's part of the switching, all right? So if I look at my base set here for a logarithm, so here's my log x, okay? Notice I'm switching. So what I put in is 1 over a, 1, and A, and what I get out is the opposite set. So I get out -1, 0, and 1. Okay, so I'm switching them out. So that is the switch. Okay, where I am is my key point is right here. So instead of being at 0, 1, it is at 1, 0. All right, and notice that basically the logarithmic graph only exists over on this side of the x-axis. So if I shade in this whole other side, the logarithm is not there because it's switching the x and the y. Okay, so there is a statement there, and the statement is the argument. So log base a of x, okay, x has to be bigger than 0. So you cannot put in 0 and you cannot put in negatives. So notice my inputs here, they can be fractions. So fractions return a negative, but my actual input is positive. So always inputs are positive, okay? So small fraction values and large exponent values. That's essentially what you've got. All right, so that's the basic graph. And notice that you're graphing it based on exponential because usually for the graphing, this is basically how I graph it. I look at what the exponent numbers are and then I figure out my log numbers, okay? So if I'm graphing these, I'm thinking about exponents first because a logarithm is essentially the inverse set. So it's a little easier usually if you think about it that way, okay? So here we are on a secondary set. So this secondary set, I want you to notice, is 0 is less than a is less than 1. So this is where you're having, your numbers are kind of backwards because you start off with a fractional base, okay? Key point is still 0, 1, 1, 0. So properties, what are my properties on this set? The x-intercept is 1, 0. Okay, unless you're moving things. So if you're adding and subtracting numbers, you can change it, but your default intercept is 1, 0. There is no y-intercept. The vertical asymptote, so the guideline that this graph that logarithms approach at some point is x equals 0. So if I look at a little graph, x equals 0 is essentially your y-axis. You're not moving left to right. I know it seems kind of backwards, but just think about it. X cannot be a number. X is 0, so x does not move left or right, and that's all your y values, okay? So the logarithmic function. Here we are looking at 0 to 1, and if you look at that graph, it's right on the right. This function is essentially a decreasing function. So it's going down, okay? Because you've kind of flipped over your values. If a is greater than 1, which is the one on the top of that, then your graph is increasing. Okay? So since they're inverses, again, here we are with the inverse statement one more time. Since they're inverses, and hey, you have these points, these are the points you have default for an exponential. If you have those points for an exponential graph, then you have to have the opposite set of points for your inverse graph. That's kind of what we did on that top graph. So what would I have for my inverse graph would be 1 over a at -1, 1 and 0, and a and 1. And essentially that's what I put up on that top table. Because I personally find it a little easier to look at it as a table set versus just a list of points set, okay? So same thing for this particular graph, by the way. If I create the table for the exponential, I flip the points over, and that creates my other set. All right. Okay, so that's how the graph works. And notice it's kind of defined in terms of its inverse graph, which is exponential. So we study exponential, then we flip the x and y sets, and then that becomes our logarithm. Okay, so now we have two definitions that we're going to define as basically special sets. The first one is the common log, okay? So if my common log is essentially saying that if I have a log and I don't see a base, okay? Base has to exist. So you have to have a base. Base must exist. So you have to have a base, all right? If you don't see a base, it's kind of like multiplying by 1. You don't have to see it to be there. So basically, if you don't see a base, then the base you can write in is 10, okay? The reason why that's called the common log is essentially before they had calculators, this is the one they would always use because powers of 10 are easy. So 10 to the first is 10. So you have 10, 100, 1,000, 10,000, 100,000. Essentially, tens are easy. You don't have to think too much about it. Add a 0 on the end. That's the next power. Okay. Vice versa, the negatives. 1/10, 0.01. 1/100th, 0.001. So again, put a 0 in front, and there's your next negative power. So 0.000000001 is some 10 to some negative power, easily found without a calculator. That's why it's called the common log. So it's kind of a historical thing because now we have calculators that help us out, so we don't really use the common log too much anymore for like manual calculations because we have better tools now. But that's where that term comes from, is because powers of 10 are simple, and so they were called common because they're easy to find, okay? So if you don't see a base, it's the same as multiplying by 1, and the common base, the base that's always there if there is nothing else that you see, is always 10, okay? So don't make up a base. If there's no base shown, the base is 10. And on your calculator, if your calculator has a log button, so most calculators will have this little button that looks like this. It says log. That is not log whatever you want. That is log base 10, okay? Some calculators have log A, B. Well, that means you can change the base because it's showing you that you can input something different. But if all it says is log, then that is a base 10 key. Don't try and use it for a base 2 or base 5 or whatever key. It doesn't work, okay? So if it says log, it's log base 10, and that is that. Next set is natural logarithm. So here's the thing. We talked about this number E last time, E approximate 2.71828 ... because it's a non-terminating irrational set that just goes on forever, like pi. Turns out this is like a growth constant. So if you're ever studying any kind of population sets, like for example, the spread of COVID, how fast does it spread? What is it doing? How fast is it growing? How many people are infected over time, et cetera, et cetera. Those calculations will involve E as a growth constant, okay? So it's an exponential constant. We only really see it in exponential sets, and it's called natural because it appears in nature, and then we're kind of stuck with it, all right? Real nature numbers, real numbers that affect actual reality are generally not pretty. Like pi is not a pretty number, but it affects all circles, okay? E as an actual value is not that great to look at, but it does have a lot of actual effects, so we care about it because otherwise our calculations would not be accurate for finding things, okay? So on your calculator, you might also have this button. It looks like 1N. So on your calculator, it might be LN. It might look like 1N, okay? That is not 1n, okay? What it actually is the natural log. So usually when I write it, I write ln. So ln of x, just to be clear, that is not a 1. That is an L. So L stands for logarithm, N stands for natural. They want it to start with L, so all logs start with the same letter. So basically, logarithm natural is how we're doing it. So what log is that? That is log. So there's our, what we're inputting there, and what is our base? Our base is E. So when you see ln or 1n, essentially that is a logarithm set with the base of E, okay? And over here, once again, it is the inverse. So if I do a set here, x, e to the x, negative 1, 0, and 1, I get 1 over e, 0, and e being approximate 2.7. So 1, 2.7, 0, 1, 1 over e, somewhere down there, whatever. Okay. Again, we're graphing, so we just, as long as we know that it kind of goes fast on one side and slow on the other, then usually it's a little better. So x, ln of x. Well, what do? Take these numbers and inverse them. So I switch them out. So my new input is 1 over e. My output is negative 1. I have an error. I really want it to be 0, 0, but it's really not. So I usually have to go back through and fix things a lot in here. So 1, 0 is my key point, and e and 1. So there's my key point of 1, 0. Okay, e, 2.7 and 1. 1 over e and negative 1, so somewhere in there. Okay, so going up on one side and flat down quickly along the axis on the other side. All right. So again, they are inverses and they switch out. All right. So that's basically what your graph looks like. This is your basic logarithmic graph right here. It's the inverse of an exponential graph, so it kind of grows along the x direction and then dives really fast down along the y-axis. That's kind of how your logarithm sets up. We have a common log, we have a natural log, and then we have our basic graphing. Okay, so now that we hopefully know this or have learned this, that they're inverses and so on, now our goal is that we should be able to graph it. Does anybody feel like they need to go back over any of this before we move on? Okay. All right, so domain. What is our biggest thing on domain? So I'm putting in something, okay? And my rule is that whatever I'm inputting has to be greater than 0. Okay, so basic domain is x is greater than 0. All right, so if I look at the first problem, and I have pretty much 2 ways you can figure out your valid domain. Okay, so option 1, figure out where it's actually equal to 0. So I look for my input, notice the parentheses. By the way, this has nothing to do with what your base is, anything outside of your input. It's only input that controls it, okay? So what option 1 is basically take my input and figure out where it actually is 0. Okay, that's where it's 0. And then I can say, okay, this kind of works like on domain sets we did before. Here's negative 3. And my question then is it on this side? Is it on to the left or to the right? So I'm not sure. So I choose a number, okay? And I'm going to choose 0 as being a fairly easy number to check. So 0 is on the right. And what I want to see, what did I say? It's got to be bigger than 0. So what I'm trying to check is if I put it back in, to my equation, which is right here, my input. Okay, so I'm putting it into there, and that's 3. And hey, yay, check. Happy, I'm bigger than 0, so this was the correct side. Okay, so essentially that is my domain. That's option 1. Set it equal to 0, just check to see where it goes. Okay, some people really like option 1. Option 1 is great. If you want to just kind of do, it's kind of a guess and check method. Figure out where you are at 0, and then, okay, so I want to be positive, essentially. So where is it positive? Some people have trouble with that because it's kind of a little bit more thinking and analysis right up front and not just number crunching. Some people like the number crunching. So option 2 is I basically say, well, I know that my input, which is x plus 3, has to be greater than 0. And there's an algebra problem. And then I just solve it. So I subtract 3, and I get x is greater than -3, right? So same rules. Notice that basically here I was checking -3. Here I find -3. So then in the end, my domain is from -3 to infinity for this particular set. Okay. B should be straightforward because x is just your input. Since it's just x, I know x has to be greater than 0. So my domain here is from 0 to infinity. And that's my set. Okay. I want you guys to do number 3. So I want you to do number 3 and come up with an answer for me. Okay. Chat it to me privately. Whatever you got for your answer. Okay. So why don't you just give it a shot, see what you come up with. If you're kind of not sure what to do, you can chat that to me too. That's fine. Just give me some kind of comment that you're actually still present in my classroom, paying attention. Like you all are. I know you're all paying attention. Okay. I don't think you can type the infinity symbol directly. So write the word infinity, or you can use INF. Because obviously we can't draw infinity. It's kind of interesting because actually math as a statement, math is a lot more like a piece of art with all the syntax and the fractions and all the symbology and the notation that it is like actual writing. Okay, so I'm getting a lot of good answers. So here's what I can see. I can see 5. I see 5. I see -5. And I see infinity and negative infinity. So I'll tell you what, it's either 5 or -5. It's infinity or negative infinity. So those numbers are all right. So we're doing pretty good. Last time I got some zeros and stuff in there. So I feel like you guys are doing a little better because I don't have anybody saying it's to 0, whatever. Okay, and I see a lot of question marks, which is also good because that means we're thinking. All right. So I'm going to give it another about 30 seconds and then we'll move on. Okay, Okay, so I'm going to show you both methods here. Tell you what, this one works better with option one. It's a little, you don't have to be quite so picky. So I'm going to start off with option two, just solving it. So first of all, negative x minus 5 has to be greater than 0. What do? I add 5. Negative x is greater than 5. But, oh no, it's negative. So what do I need to do? Probably multiply through by negative 1. So I'm going to have x. Negative x times negative 1 is x. 5 times negative 1 is negative 5. The key here, though, is, unfortunately, this, since it's inequality, not equality, when I flip things over by a negative, it has to flip that inequality sign the other way. So algebraically, that's my answer. But if I didn't see that part, you could have an error there because you flipped it incorrectly, okay? So that would be the correct answer for option 1. And then we write our domain. So option 2, I mean. So for option 1, then so first I find out where actually it's 0. Negative x minus 5 equals 0. Negative x equals 5, adding 5 to both sides, and then multiplying both sides by negative 1. I get x equals negative 5. So on my number line, negative 5 is either my domain. I have two choices. Choice 1, it goes off to the left. Choice 2, it goes off to the right. What I know is that this piece here has to be greater than 0. So what I'm checking is negative x minus 5, okay? And I choose a number. Doesn't matter what number. I'm going to choose 0 again because that's a pretty easy number for me to check. So I'm going to choose 0. So basically you put 0 in for this and you see what happens. Remember, negative 5 is the divider. So I get 0, negative of 0 is 0, minus 5 equals negative 5. Oh no. Oh no, no. Okay, that is negative quite clearly. So that means this side is an unhappy side. So it can't be that side. That means what? It's this side. This is the domain on that side, okay? Essentially, it's a guess and check strategy. Where are you putting your value you're checking? You take your value you're checking, you put it back into your input set. So basically that into there, and make sure that it's positive because I know that my input has to be greater than 0. Again, kind of have to think through it a little more. It's really a choice. It's really a option, okay? So one or the other. Some people like the first method, some people like the second method. It does not matter because you should get the same answer either way, because you'll notice that basically we're saying, hey, I'm over here in the less than 5 area, went that way. And this is also saying less than 5, negative 5. So what is my actual domain set? It is from negative infinity to negative 5. Okay? So that would be my domain for that one. All right. So last thing we want to be able to do today is actually graph logarithms. Okay? They have some steps here. I'm going to tell you that my steps are different. My step is star 1 graph. Okay, graph. I'm pretty much going here. So graph, then find your other stuff, because honestly, trying to do the domain and the range first without the graph is really hard for me. So I prefer to find the graph first and then figure out what's going on. Okay. So here I am. I honestly don't know why the range is down at the bottom, but whatever, it is. default notes. I didn't get a chance to edit these before you see them, so I'm sorry about that. So first of all, for me, logarithms are inverses. So the first thing I'm going to do is make a table of the actual inverse. So I'm going to choose y as my variable because I want to remember this isn't my real graph. And I want you to note that my base is 2, and so what am I doing for my exponent base is putting in 2. This is just for reference to help me figure out my actual points, okay? So let's see. I'm going to put in -1, 0, 1, and 2. And what I'm going to get is 1/2, 1, 2, and 4. I'm going to pause there for a second. If you're not sure how I got those numbers, okay, I'm going to pause for a second. Okay, so here we are, right? What am I doing over here? I'm building my graph. So I'm building a table for my actual graph, x log 2 of x. Notice I'm not doing any weird transformations or whatever. So this is a direct set inverse. So if my key point here on this one is 0, 1, then over here my key should be, if I put in 1 log of 2 of 1, so anytime you have a logarithm of 1, it's going to be 0 because that's essentially the inverse exponent set. So I put in 1 and I get 0 back, okay? So that would be my key point for this graph, so 1, 0. Okay, and then I'm just reversing things. So I see the next point here. Here's my next point, 2, 1. That means in my actual graph, I need to put in 2. Log base 2 of 2. So what exponent of 2 gives me 2? Well, that would be 1. And it should inverse this set. So basically, it should reverse that set. So I put in 1, I got 2. I put in 2, I get 1. So notice I'm using this inverse table to basically build my set. All right. So 2 and 1. And then the last one, top line, top set, 1/2, -1. So 1/2 log base 2 of 1/2. What exponent of 2 gives me 1/2 is what I'm thinking about because that's logarithms are exponents. So what exponent of 2 gives me 1/2, and that's -1. So 1/2 and -1, and I should be able to see my logarithmic graph. Okay. Vertically along the axis and then kind of rising horizontally. So domain 0 to infinity. Asymptotes y equals 0. I can never have a y value that, or an x value. All my x values here have to be either fractions or regular numbers, but never negative. And then the range down on the bottom, negative infinity to infinity, okay? So domain, asymptotes, and range, and notice I did those after I graphed the graph, okay? So I start with graphing it because it's easier for me to graph it first and then look at the graph to help me figure out the rest of the key points. All right. So let's see. Okay, what I'm seeing here is I have a logarithm and I don't have a base, okay? If I don't have a base, that's essentially common log. So it's common. That means my base is 10. So I'm thinking about my inverse set. Again, I'm going to just have a couple of points for an inverse set. And again, I'm going to use y. So I remind myself this is not really my points. Negative 1 and 1/10. 0 and 1, 10. No, not 10. I don't want to do 10 to the 10th. That's ridiculous. 1 and 10. If I want another one, 2 and 100. Okay? So let's see. Key point is that point right there. The one in the middle, the 0, and the 1. So let's build my set. Notice on this set, I am doing some changes to my original set. So log negative x minus 2. That looks like this here looks like there's going to be some kind of flip on the x. And then this, I should know that the minus 2 there means it should move down 2 units, okay? But I'm pretty much going to start with my key point, which is going to be, let's see, log. So my key point input needs to be 1. And what I am noticing here is that it's negative. Okay, so if I put in 1, then what I'm going to get in here is a negative 1. So that won't work. So what I need is opposites, right? So my key point is I need to put in a negative 1 so I have a positive 1. So I'm just being careful and making sure the signs and everything work. So I can input 1 and get essentially 0. So this turns into 0 and then minus 2. So my answer here is negative 2. So my key point on my actual graph is negative 1, negative 2. That is my actual key point. And that's making sense to me because my original key point is probably on the axis. Original key point on the axis here, notice on the other side. So the minus 2 says down 2. That looks good, okay? The negative x kind of says it should flip over, so that also looks good. So I think that that is okay right now, all right? So let's see. Next point over here. If I'm looking at this as my next point, let's call this point A, okay? A. So if I'm saying I want to input 10, but I notice that, there's a negative, so I don't want to actually input a negative 10. So if I want to put it in opposite, basically what I need to do is say, hey, that's got to be negative 10. Because then negative of negative turns that into positive 10 for input. Okay, what exponent of 10 gives you 10? Well, obviously that's 1. That's what that is showing me. So that's got to be 1. minus 2, that's negative 1. So negative 10 and negative 1. That looks pretty good for that side of the graph. Kind of using this as sort of, it's supposed to kind of flip over, so it should be going the other way, which it looks like it does. And let's see. So I'm looking at that I'm putting inputs in opposite. So obviously if everything else is negative, that's also got to be negative. So negative 1/10, and I'm pretty much up here looking at that, all right? So negative of negative is positive. So what am I inputting? Positive 1/10, really? Minus 2, that's negative 1 minus 2, that's negative 3. Negative 1/10, heavens, negative 1/10, negative 3. So somewhere along there. Okay, that looks pretty good. So this is how my points should connect, okay? Now I have my graph. Now I do the domain. So now I have this. Now I think about the domain and the asymptotes and the range. So I do that after graphing. At least for me, it's easier to graph first and then figure out the rest of it later. Okay, so if I look at my graph, I can see the left, right. I can see what I see is an arrow over here and an arrow going down, but not an arrow over here, an arrow going over. Okay, also I know there's an asymptote because it's logarithm. So my domain is going to be from negative infinity up to 0. And honestly, that makes sense with this fact that there's a negative x in this set. Okay, so that negative x right there is going to flip the domain left to right. Asymptotes, default asymptote. Oh, I have an arrow over there. I can see it. Oops. Should be x, x, x equals 0, y-axis. Or maybe you just say y-axis. Maybe the equation is stressing you out. So I would also accept, hey, my asymptote is y-axis here. Okay. X equals 0. Also, if you're having trouble with the equation, you might want to just draw in your asymptote and label it. Because if you've got it on the graph, then I will know that you knew where it was, even if you messed up on the equation, so you can at least get some partial credit on that. All right, so then my range, I'm going to draw it over here, negative infinity to infinity, okay? Because it keeps rising to the left. So I've got an arrow going down and an arrow going up. Okay, that's pretty much it for today. There is going to be a quiz. That is your assignment for Friday. I just don't have it quite ready yet, but that's it. All right. And that's it for today. So if you have any final questions, then you can ask, or otherwise we're good. Okay. So that's how I graph these. I kind of look at I kind of build an inverse set to kind of help me like figure out my points, because I find them confusing, honestly. All right, so hopefully that was helpful, and I hope we all can come back together on Monday. Okay?
Thank you.
Thank you.
Thanks, guys. Have a great day.
You too.
Thank you.